3Blue1Brown proposed this problem.
My puzzle for you is, what is the probability that the very last number to get colored is the 6?
So the ladybug starts at the 12 and it has to reach 6. And every time it moves, it has a 50% chance of moving left and moving right. At first I did not know how to solve this, so I tried an alternative method for the answer, and it is through coding. And I'm going to use the Monte-Carlo method, and I'm going to show you how I did it. We need random, a list where we keep track of the visited numbers, a variable that keeps track of our current position, a counter which tells us how many times we had 6 at the end, and the number of iterations, how many times we want to run the simulation. We are going to run it this many times. One iteration stops when we had visited all the numbers. Let's create the simulation for the jumps. We are creating a random number, which can be 1 or 2, and if it's 1 we are going to move left, and if it's 2 we are going to move right. We should not forget our edge cases, which is 1 and 12. Now let's make the right jump. Now let's see if we had already visited our current position. I see I've made a mistake. If it was not already in, let's add it. Now at the end of the simulation, let's check if the last one was a 6. If it was, let's update the counter. And don't forget to reset the list and our current position. And at the end, let's print the result, which is the number of times we had hit 6 at the end and the number of iterations. And let's check the results. I actually switched up these symbols, but let's fix that. And we got around 10%. The actual answer is about 1 over 11. About 9% is a good guess. Now let's see what if we actually increase the number of iterations. It takes longer, but our result is much more accurate.